Hello everyone, here's your 5-minute Activity 1 overview. I want to make sure that you remember this materials page because on the materials page is the topic for alternatives energy. And what you have is all the videos loaded up, and I've got some really good videos here for you. I've got one here about the geometries, I've got another one here about covalent bonding and Lewis dot structures. I have the PhET models here for you, build a molecule and molecular shapes, so you can look at these shapes while you watch the videos. If you scroll down to Activity 2, I've got one PhET model here for the molecular polarity. Here's your evaporation video that everyone should make sure that they understand. I've got another one here about polarity and a final one about intermolecular forces. So please watch these if you want some review of this type of material. I actually want to go over quickly this the reading and how it applies to the activity. Well, first off, there's two types of forces, intramolecular and intermolecular. Intra is about this over here, and it's about the polarity of a water molecule. And you can look at the video about polarity to understand about how the atoms, when they're put together of different electronegativities, will cause these separation of charges. And then there's intermolecular, and that's about the bonding between molecules. Well, let's look closely at this intermolecular. They make these dipoles is what happens. They call this dipole attraction. Well, what is that? Well, that's just saying that there's a plus or a minus on a molecule. They attract, and so you can get molecules that will attract each other based on their pluses and minuses. What's really interesting is this hydrogen bonding. It's a special type of dipole-dipole interaction that has to do with hydrogen. And water is one of these ones that have this. So here's an intermolecular force where the little minus of this oxygen, it's associated with the positive of the hydrogen. And that came from up here. All right, so the polarity makes this hydrogen bonding. We scroll down, and in your reading you also had this thing called London dispersion forces, and this one's kind of really a little more difficult, and all it says is that there's an instantaneous dipole in an atom that doesn't have any dipole. It's all nice and it's got a plus and everything's fine, but this instantaneous dipole will give you these dipoles that can attract each other, just like up here. What does this mean for our molecules? Well, it's all about the stickiness. The stickiness of molecules. These intermolecular forces make molecules sticky, and they determine the evaporation. So look at the evaporation video to make sure that you understand evaporation. Let's take a look at our data real fast. We have methanol, we have ethanol, propanol, and butanol. And methanol, I would say more evaporation. It was cold. If I'd put it on my hand, it would have been like brrr. Butanol, less evaporation. I think the temperature change was only about 2 degrees C. I think this one over here, methanol, was about 25 degrees C. Well, methanol is less sticky, obviously. Butanol was more sticky. Okay, well, let's go down and look at another data set. We have pentane, hexane, and heptane. Pentane should have been more evaporation and cold. Heptane, less evaporation and warm. So more sticky and less sticky. Pentane less sticky, it evaporates. Why? Well, we can go back to our reading and look at this idea of London forces, okay, become more significant as the size of an atom or molecule increases. The larger size means there's more electrons. All right? Heptane, more molecules, or I mean more atoms, more electrons, stickier. Same thing here. Same with butanol. Bigger, more dispersion forces. Stickier, less evaporation. Methanol, not a lot there. Now we can compare the two, but we're not going to go that far. I don't want to go there. Okay? We're going to leave that alone, or you can ask me in class tomorrow morning. And what does this all have to do? It has to do about distillation and crude oil, and you can heat it up and get out fractions of crude oil depending on the stickiness of the hydrocarbons. And they do this all together in a single condensing column where things come out, bigger things come out here and smaller things or molecular weights come out there. I've run out of time. Look over these videos and ask me questions on the comments or tomorrow. Thank you very much.